Hi everyone. So if you don't know me, my name is Yonatan, or Yoni, the short version of that. And my life kind of divided between two main parts. I'm part of very fast growing startup Monday.com. And by night and weekends, I'm leading the largest Android community in the world with the main goal to give everyone an opportunity to learn for free. And today we're going to talk about the memory. And when I started to build this presentation, I was thinking about one of the favorite quotes Bill Gates made about that 64 hundredths of memory, kilobytes of memory, should be enough for everyone and for anything. Oh boy, how he was wrong. Back in my childhood, my first PC was 286, and it was like astonishing. Like I played games, I first made my programs like X editor, if you know, and I was inspired by all this amazing thing under my hands, and it had only 60 megabytes of RAM, like of the memory to use. The world is like evolving and moving forward, and today we have very powerful PCs, Macs, with 32 gigabytes of RAM, like crazy. When I started development on Android, had my first phone, and it had only 192 megabytes, like a little bit of money of RAM. And we had this huge, one of the top crashes that we had back then was out of memory error. Right? We suffer a lot from that. It was really a headache to deal with that. And today we have like very powerful devices with a lot of memory. Even some devices had like 12 gigabytes of RAM, this small device, and very powerful. But somehow in 2022, we still have the same problem of out of memory. And it's like when I'm looking at the crash, I'm saying like it's new per device, like it's top edge, and they have over 1.5 gigabyte of free RAM at the time when the crash occurred. Like, how come? Where's the memory? What's happening? And in fact, actually, the first sign of this problem, that I thought there is a huge amount of RAM on the device, but it doesn't matter because your app is limited for 268 megabytes in overall. So this is what you can use for all shiny things in your app. And out of memory is just is a tip of the iceberg of all problems that happen in your app and in your app. And you need to take care of them. And because if you don't, then your users will suffer, they will hate your app, and then they will leave you. This is the same happened to us in Monday.com. So when I joined, we were a small startup. We built things very fast. We have this main component called board. Basically, you can think as very smart, complicated Excel with smart columns, a lot of different columns like status, persons, a lot of items, a lot of business logic involved, and we built for that caching and database and live observation of this database. And actually, it worked really well when it was small. But then we started to have many different customers, and they had huge boards that took time to load, and they were laggy, and eventually we ended with the out of memory exception. It's like they put it in reviews. We saw it from the Crashlytics. Like all our users were suffering, and said like, okay, it's clear there's a problem. We need to fix it. And before you rush to fix something, in order to do it right, you need to understand the basics. You need to understand how the things are actually working in Android. And for that, we need to learn basic stuff, and we start with RAM, random access memory. So basically, RAM is the fastest available memory inside device, and they divide it in different parts. So we have this memory that occupied by operation system itself. It uses memory to run the stuff. We have other apps that live in our device, like Home Launcher, other apps that user interacting with, foreground services, and then we have like buffer and free RAM. So all our RAM that we want to use is actually this part, like buffer plus free. Actually, you can check if you go to the developer options and running service, you will see the same picture, who occupied how many memory. And when you launching your app, you're clicking on the icon. So what's happening is that intend to send to the Activity Manager service which activity to launch, and then Activity Manager service is actually going to the Zygote, the one that managing all JVMs inside the device. Is took the one, returning back the process ID. In what happened next is actually it's binding, it's loading all the classes that it needs to for the application to run and binding into the process. And then it's called for launch activity, our main activity, and we get this callback on create. So basically, this is the first time the user will going to see something. Amazing process. So when you have available RAM, it's everything okay. Your app just gets inside in RAM, everything is loaded, fine. But interesting thing starts when you're launching the app, the RAM is full, and you need to clean it in order to run. So what's happening is called swap or kill. On the PCs, on the modern PCs or the Mac, what is happening is when you don't have enough RAM to start application, it's actually what's happening is take a piece of the RAM and save it on the disk itself, on the hard disk. And when you're coming back to this application that was saved, it's actually loading back this entire memory to the RAM. And this is actually how the multi-processing or actually multi-applications is work on the PC. On the mobile, we don't have it because we have a limited amount of write and read operation over our storage. So what happened instead is trying to zip our RAM for the apps that is not used right now. It's trying to zip it and then unzip when we come back to this app. And if there is no any available apps to zip and to free the memory, then there is out of memory killer that comes into the game. And the game is pretty simple. So we have this activity manager and a lot of different apps actually that there are processes. And for every process, we have the score from -50 to +50. And the lower score means this is the application that the user are interacting with right now. So the activity, the application that I'm have open on my screen will have the lowest score possible or foreground service. But the application that actually running on the background or not doing anything will get the highest score. And then when the out-of-memory killer comes, it bring threshold, say like, give me all these processes that using more than 10 kilobytes of memory and have this score of 7. And then it just kill them without any mercy and free memory by that. So how it's connected to our application? It's meaning that if we're using less memory, we're likely to survive. So our user will be more happy because they will not experience this cold start, waiting time, and you as a developer will not need, your users will not need to load again the data that they used before, etc., etc. And in order to understand how to use less memory, we need a little bit to understand all this stuff, heap, stack, and how the memory is used. So this is the simple program that we have two functions, main and print params. They're allocating something. So I'll just go briefly about that. So we have this stack that actually, when we call for the function, it's going to create this block for the stack. And when we allocate something, so if it's primitive types, it's allocated on the string. And if it's an object, then it will be created in the heap, and the stack will going to have this reference. And then we will create another object, and then it's again on the heap, it will be object itself, and in the stack we're going to have the reference. And then when we call for another function, another block of stack will be called. We'll have another reference to our object that created in the heap. And then if we'll, for example, we'll create a string. So actually it's the different because we have string pool, and it's going to allocate string from the string pool. And the funny things is, interesting things happening when these methods are over. So when our print param is over, it's just popping up the stack with all primitives that are allocated and they're all reference. And when the main is over, happening the same. So basically, when our program is finished, we have clean stack, but things allocated in the heap, and they stay there until we will have garbage collector that will come and clean the stuff after us. So if you already profile the app, you saw this recycle bins that actually they mean that there is garbage collector that's doing some stuff to free memory. And the main goal of garbage collector is to find the objects that can be accessed and then to reclaim the resource back, like to clean those objects. And the process is called GC concurrent on Dalvik or concurrent on ART. And it's called mark and sweep. So basically it's take this root, GC root, and then it's try to mark all these objects that can reach. And for those that can't reach, they sweep them out of the memory by freeing them and make our heap smaller. So what is GC root? Who is it? So basically it's a bunch of different references, like it's a class that's loaded by a class loader. It's like static fields in Java or Kotlin. It's a local vars in our stack trace. It's a new created trace, synchronization monitor, or GNI reference. All of them are GC roots. Another way to, hard to remember, but another way easily to find those is when you open the memory profiler, you will see those that have def of 0, there are GC roots. For example, here we see like S instance inside our class, it's a GC root, a static reference. So in Android, what happens like when the GC concurrent is called, so it's trying to free the memory. So we have this different operation that happens. So first, it's finding the GC roots, and it's happening concurrently. So our application continues to run. And then it's go and try to find those that are reachable, and it's happening also concurrently. And then it's doing another pass, but actually in this time, it's pausing our execution of the application. So our main thread is waiting, it's doing other stuff. And then it's actually freeing the memory, it's happening concurrently. So it's happening very efficient, like to freeing 23 megabytes, it took 52 nanoseconds, like very fast. But what happens when you need to allocate more space for your object? And then actually the things become a little bit messy. So it's called GC for Aloc, or Aloc in ART. And it's actually will stop everything, will try to find GC roots, then we'll go to find those reachable objects, and then suddenly will free memory concurrently. So the whole pause will be much longer. And what happens when our heap is full? Then actually two things are happening. Or we're going to have our heap is growing, become larger heap, or on Lollipop and beyond, it will try to perform defragmentation in order to put new created object in the sequencing. But then what happens when we have object that can't fit into our heap? Then we're going to have our famous out of memory exception set. And actually the funny thing that if you will look in the Stack Overflow what to do with the heap size, actually you will get this still very popular answer to put Android larger heap true inside your Android manifest. But the thing is that it just will allow your app to create more garbage. The whole process of finding these GC roots to mark reachable objects will take much more time. So your app will pause for a longer time, and actually your CPU, instead of showing something to user to make the app interactive, will spend more time on those GC cycles, and actually your user is going to suffer. And the first sign is that you will going to see in your logs this bunch of outputs of GC doing something like allocation, GC for Aloc, concurrent, etc., etc. It's a good sign that you need to check and profile your app. Why I care so much about the memory? Not only because of the out-of-memory crash, but actually because of the user interaction. So everyone heard about 60 frames per second, especially the gamers among us. So if you will look in the log, there's someone called choreographer, and he will cry constantly if you have a problem with the memory, that you're skipping a lot of frames. And actually, it might be a little bit confusing because they say that your application might be doing too much work on its main thread. And it's a mistake that because usually people are what they're doing, they start to looking what I'm doing in main thread and try to outload. But actually, the problem is not only of the stuff that's happening on the main thread in your app, because all this memory freeing GC is also happening on the main thread, is stopping your main thread for execution. So how this entire thing of 60 frames per second is working? So we have this flipbook, and it's running less or more like showing, if you will, it's working, it's running with the 12 frames per second. It's quite noticeable, right? So this is actually it's a flipbook, it's not a movie. Modern movies are running with a 24 frames per second, and using different effects. This is actually our movies today. For gamers with us, so we are strive to buy new graphic cards in order that all our games will run with a 60 frame per second, because this how our eye can distinguish everything, any animation up to 60 frames per second. And everything above it, actually there is no difference. Our eye can't feel the difference between 60 frames per second and 100 frames per second. It's still same smooth motion that happen on the screen. So if you want to be on the 60 frames per second, what does it mean? It means that we need to draw on the screen to refresh our pixels every 60 milliseconds. And what happens if we have this GC cycle running at the same time we want to refresh the screen? Well, we will drop frames. So you got the idea. You need to take care of the memory. You need to profile it. But what next? And I will give you a couple of reasons actually why all these things can happen that you can look onto this. So first of all, when you're doing a lot of allocations, they're affecting your memory. When you have a memory leaks, it's affecting your memory. It's like piece of chunks that stay forever. And you can use tools like leak canary that can help you to find those leaks, and not designing for performance. And I will give you here a few examples. So memory churn is when you are locating a lot of the objects in a single point amount of time. So here, like we are creating Hulk 1000 times, right? Like in a multiverse, there's a lot of Hulks there. And what's happening, like it put huge pressure on the memory because we created a lot of objects at the single point of time, and like we are releasing them. So there is no hard reference for them. And the GC need to work very, very hard. You see a lot of different recycle bins to clean this memory, and you will look and log, I spent more time on the GC rather than showing something to the user. And when it's happening, usually it's when developers are using custom drawings, so custom views, so they put in on-draw method, new allocations, very affecting, or by reading streams and concatenating into the string, like reading from the network, or inner loops allocation, that one you said before, or actually in the Kotlin, when you take in the collection, like list, for example, and doing like map. So basically you are allocating new objects very fast. So a collection might be very huge. So like you're increasing your memory then to release it next. Another really common mistake is active observation of a DB. So we have this huge amount of items, right? So what happened? Like we have this database, and we can use Room with the flows to actively observe on everything that happened in these items. But what happened is that when we're observing, using this flow, using coroutines, we actually have this entire chunk of all items in our memory forever, as long as our coroutine is active. And think what might happen if you accidentally will get a lot of items from the server and save it in the DB. So you will observing all these 3,000 items in it when your coroutine is active, like huge amount of memory. Best advice, like use pagination always from the day one, because once you start to exploding, very hard to maintain that. And the JSON, JSON is a very powerful tool, but the problem is that it's generating this JSON tree and storing in for the cache purpose in memory to speed up the performance for the next calls. And it's very affecting your amount of memory is used. So probably you want to switch to better alternatives. And of course, it's just a piece of advice is where to start to look. And the most thing, like, don't afraid to profile. You will find a lot of different things happening in your app that unique for your app, like memory leaks, allocations that really exploding your memory. And it's the beginning. It's very hard. You feel useless. You don't know where to go, how to fix it, what's happening. But actually, this is what will make you the best developer out there that knows and understand how the things are working. So I wish all of you good luck with this journey, and to have this 99.9% of crash-free users of memory out of memory issues. So thank you. Yeah, you can applaud.
Yeah, we don't hear applauses here in the studio, unfortunately. But Yonatan, I have to say you have shitloads of comments and questions.
Wow.
I hope we'll have enough time to go through all of that. Actually, if I'm not mistaken, we have 7 minutes for Q&A.
No, 2 minutes.
That's 2 minutes to the end of the session. I believe we have more, 11 minutes. Thank you, team. We have quite a lot of time to talk about that. Should we jump straight into that?
I'm always yours.
Great to hear that. Actually, I'm going to start with commenting on 60 FPS.
Okay.
I don't know if we knew each other when I was building games, but 60 FPS was something like you have to do 60 or more. If you are not hitting that bar, forget about your game. It's just not gonna fly anywhere.
Yeah.
And it was interesting that you mentioned that because in gaming, it doesn't make sense to go beyond that unless you're doing some simple games. What FPS you're trying to optimize for in Monday.com? Do you actually do profiling for that? Do you track?
So we had this. So first of all, it's very hard to understand at which FPS level you're running right now. There are some tools, and we used to use those tools. So one of my teammates, we use this plugin to understand what's the current FPS, but it's very hard to use on a daily basis. So we use it once to profile our app, to optimize where it can be optimized. But you don't need these special tools to understand. You're just how many frames you're drawing in general. You can see they have this all built-in tools in Android Studio. So you have this. First of all, you have all logs output that if you're going to skip the frames, it's going to stay. And you have this Firebase that says how many freezing frames you have, how fast you can launch activities, etc., etc. So we have dozens of tools that are available for free. You don't need any to work to integrate those tools, and trust me, you can achieve a lot of improvements with that.
As we touched about the tools, lots of questions, and I'm going to just group them all together. Was about tools. Can you walk us through what is your tool chain on Monday.com to detect memory leaks? Do you have any automations for that? Basically, how people can avoid memory leaks?
So first of all, how to avoid memory leaks is to be aware. So
good start.
Yeah, it's you need to understand what does it mean GC root, right? So now by now you understand, and now you can look on every single static field in your Kotlin app. Very suspicious because it can potentially leak stuff, right? Any new started thread. So in Kotlin we're using coroutines, but still there's a lot of applications out there. So first of all, to understand from the code, what are you doing right now? The second thing, so there is a tool, Leak Canary. I think it's a great one.
There was a question particularly about Leak Canary.
Yeah, so we use it, but the thing is, it's a great tool. Help you to discover. So I was working a lot on profiling on a Monday.com app, especially on the boards, because this is the heaviest part, and we were leaking a lot of the things. I was sending to folks how many megabytes of memory I cleaned today, literally every day. Today it's 64.
It sounds like it was a challenge.
Yeah, exactly. It was really a challenge. But the thing is how you maintain in ongoing effort, right? So basically, it's obviously it's not enough to invest. You take 1 week, you clean on memory leaks, but tomorrow someone going to introduce another one.
Either should be a process or some automations.
So we started by first integrated in all our builds. So basically it will run by default in debug. And instead of saving it on our device, I built when I wasn't Get, we built this integration with Slack. So yeah,
Okay.
you get this leak that published to the channel that everyone can see. So it's not just like on my device and I can ignore it. It's just out there in Slack. So you try to, as much as possible, to expose this information to the outer world, and then like if you constantly get this popping notification about from the memory,
Probably you need to fix it at some point.
Something wrong. We need to fix it. And other tools. No, basically this is the tools. And back to the question how I profile all this, how I'm using. So it's going to surprise, but I'm using only Android Studio, and actually in Eclipse we had this DDMS stuff. Remember?
Yep.
And the reason why I'm using that because when you have like, and we had in our when you're trying to load huge board in Monday, like thousands of items, it's like you have so much memory used that Android Studio was crashing. It wasn't able to show me the dump of a heap.
Yeah, like killing the profile is like meta level of leaking.
Yeah. And this is DDMS tool. Actually, it's the one that succeeds to.
Okay.
And
interesting.
And then actually, it's just to look how many instances of the same class you have.
Yep.
Supposed to be there, not supposed to be. Who allocate them? It's hard work, but there's no like workarounds or shorts for that. Like work that need to be done.
Do you have any automations? Like I remember back in my previous company, we used to build a SDK, and like we'd better not leak memory in SDKs that multiple people are using. Like we had a number of automations that was actually checking the memory usage in the couple of standard scenarios we've been running through. Like, do you have anything like that in place for Monday.com?
So we had this. We're using CoralLogix. It's basically it's a logging tool. So
something like fancy Firebase,
very, very fancy. Like Firebase, the problem is a great tool, but it's very limited, right? So I want to search something.
It's to cover like 80% of markets, like basic scenarios.
Yeah, I'm not sure because like
not even that.
Yeah, because like for example, you want to search something in these logs, right? Or across different users, you want to search all those users that have this, right?
Yeah, makes sense.
And you can't, right? So you need to use, because logs are per users and they're not searchable. It's just one of the examples of the scenario that very useful. So for example, you want to see all these users with the logs that reaching certain pressure when loading board, for example. So we're using these CoralLogix, and they're using Elasticsearch behind the scenes, so they're indexing all the logs.
Get a fancy.
So you can search for all these logs to understand what happened, to get the user's ID, and then to see the entire journey, and then like we were printing how many memory we are using.
Okay.
Also, you can define automatic alerts on that. So we like if you have this board with a certain amount of items that using more memory than it should, above the threshold, then you can get automatic alerts to Slack, to your phone.
Do you wake up people in the middle of the night? Like, hey, there is memory?
So actually it is. We have this PagerDuty tool. So it can be connected.
I put it out as a joke, but like, okay, that's impressive. That's impressive, I have to say. Michael is saying, thanks Square for a lead canary.
Yeah, definitely.
Thanks for comment on this one.
Yeah.
Another question was, that one is kind of specific. Have you tried using Android's .content.component callbacks to in Monday.com app?
I'm not sure I'm good at answer. Got a question.
I believe like that was a feature. I'm not following Android. Like I didn't follow like the latest updates, but as I remember, component callbacks too is just like a way to trace memory in the application in real time. You can correct us in the chat if you are listening to us right now. We can get back. Actually, if you have questions specific like that, we are, I see, running out of time. We have less than a minute left.
Yeah, we'll have a breakout room.
Yes, right after the session, Yonatan is going to take a break, probably a minute or so, run upstairs to our another studio office, and join a breakout room. So like, if you want to have a detailed chat with Yonatan on component callback 2, please join the breakout room. Live stream is going to be recorded. We're going to have like 10 minutes break. Yeah, we actually have quite a lot of time before the next session, so please join breakout rooms. It's just like next tab next to the live stages in Hopin. And you can catch Yonatan there.
Yeah.
And at this point, as like timer goes red, thank you, Yonatan. It was amazing. Thanks for flying over to London. And as always, it's a pleasure to have you on DevFest. And looking forward to see you in person in Ukraine.
Yay.
Thank you. Cool.